So guys, now we are going to see the another two techniques which are the word. First and the foremost thing is called as the of your zone refining. So let us now first deal what is the main principle involved over here. It says that impurities are more soluble in the melt than in the solid state. So what does it mean if simple words if I have to say that your impurities are having the low melting point than that of your metals. Let us see that how you are going to do or how you are going to refine your metal through this technique. So let us consider your impure rod. Okay, so this is we can consider this one as that of your circular disc. Okay, or we can say moving circular disc to be more appropriate. That means what? It can move from one point to the another point. Remember, this circular disc is heated. Okay, so what happens, for example, if I consider this one as my initial position. So this circular disc, that is a heated moving circular disc, is trying to move from that of your initial position to that of your final position. Since the main impurities are more soluble in the melt, so as this coil or the disc is moving, along with it what happens, the impurities, whatever the melt is there, that will be also moving along with this coil. And they will be concentrated to that of your final position. Now what happens when the coil reaches over here, it will be cooled off. Once again the cooled coil will be taken back, and once again we are going to start the process by heating the coil and moving it from your initial to final position. Like this many times will be done. So what happens, whatever the impurities, even though it is present in a trace amount, that will be collected in at one end. Since we are creating a zone of impurities, it is named by that of your zone refining. So very much important, and many times they have asked you the main principle and you have to write it in the same way what they have said over here. Impurities are more soluble in the melt, that is the reason what you are happening over here, than in the solid state. So by this way, we can easily obtain. So making a main change, we have to say over here that it is mainly employed for that of your semiconductors, because we need them in a ultra purest form. So in order to obtain the metals in the ultra purest form, this zone refining is one of the wonderful methods, because you could see that again and again we can easily remove whatever the impurities are present in it. That is the reason. Okay, coming to the last and the most important part of the technique of your refining, which is called as vapor phase refining. Of course, by here itself you are getting the word or a hint by which way we are going to refine your metals. That is by your vapor phase. So guys, here one important thing we have to remember that. So this vapor phase refining is the technique where first the metal is converted into its volatile compound. The metal is converted to its volatile compound. That is the reason. So what you are doing, you are converting your metal to a volatile compound. That is like your gas in a vapor phase. So how we are going to do this? This is done by utilizing certain reagents that will be seen now. Okay. So whatever this volatile compound will be created, that will be collected in another chamber, we can see, or they will be collected somewhere else. And whatever that collected compound, that your volatile compound will be there, that is then undergone thermal decomposition. That is, you are going to heat it at a very high temperature. So what happens at when you're doing it? So after this thermal decomposition, we will be getting that of your pure metal. So this is the main technique or the main principle involved in that of your vapor phase refining. So what are the important requirements if I just make it as a point wise? Of course, the first of all, the metal should be converted. Metal should be converted to that of your volatile compound. Yes, by using the available reagents. As I have said, this is your industrial process. It can't be very expensive. So in cheap means we have to invest and we have to profit much more. So whatever the reagents which will be easily available for us, those reagents should be utilized to convert your metal to that of your volatile compound. It is your first requirement. Second one is what? Whatever your volatile compound is there, that should decompose very easily. that should decompose easily. So that what happens, our time will be not be wasted and we can recover the metal at a faster rate. So recovery of the metal can be done at a faster rate. So this is the one of the major important two requirements in your vapor phase refining. So what you are doing over here is, first we are converting your metal to that of your volatile compound, and that volatile compound is collected in some another chamber. Then in that chamber we are going to heat it, because we are undergoing it as a decomposition at a very high temperature. Once it decomposes, what happens? You will be getting that of your pure metal. So in this technique we are having the most important two types. The first one is called as that of your Mond's process. It is called as that of your Mond process. It is mainly involved for refining of nickel. Now let us see what we have said in the initial. So of course your metal is your nickel. Okay. So what we have to do first, we have to convert this metal to volatile compound. Of course I said how we are going to do, by utilizing your available reagent. So what is the reagent? Let us see over here. So nickel in the presence of your carbon monoxide, yes, nearly maintaining a temperature of 330 Kelvin to that of your 350 Kelvin, it will give you the complex. Can you be able to understand? NiCO4. So remember this nickel tetracarbonyl, or what you can the name, IUPAC name, please remember. What is the oxidation state of the nickel over here? Of course it is 0. Yes. So what is happening over here? Now this is what your volatile compound, yes, which has been prepared with respect to that of your available reagent. Now this volatile compound is collected in some another chamber, which will be now subjected to the very high temperature of nearly how much? 450 Kelvin to that of your 470 Kelvin. So what happens? Nothing much. We are going to break this now. Thermal decomposition. Thermal means what? Temperature. Decomposition means breaking off. So what happens? Of course you will be getting as your pure nickel plus that of your 4CO. Simple process. What you have done initially, the same part we are going to get at the last. But remember, this nickel is having the impurities, but whatever the nickel you obtain after the vapor phase refining, that will be the purest nickel. So this is the one of the method of your vapor phase refining, which is called as Mond process, mainly used for the refining of nickel. Coming to the another part, it is called as your Van Arkel method. Van Arkel method. So it is mainly employed for the purification or refining of your zirconium and titanium part. So of course here zirconium is your metal. So first what I have to do, I have to convert it to that of your volatile compound. So how we are going to do it? So basically your crude metal, that is your metal having that of your impurities, it is first heated in an evacuated vessel, okay, with iodine, I2, yes. So first what it will do, it will be get converted to that of your volatile compound, it is your zirconium iodide, ZrI4. Since this ZrI4 being covalent in nature, okay, they are then thermally decomposed, and they are very much specific where it has been decomposed on that of your tungsten filament. Tungsten filament, yes, at nearly the temperature range is 1800 Kelvin. Why we are choosing it? Because tungsten, because it is having a very high temperature resistant. Even at this high temperature, this tungsten is not going to melt. That is the reason we have chosen the tungsten over here. So this zirconium iodide is then heated on this tungsten filament. Of course, you are going to get that of your pure zirconium plus with the evolution of your iodine gas. So whatever the zirconium will be provided, whatever you are going to obtain, that will be what we can say deposited on this filament. Okay, your zirconium, whatever you're going to get as a pure zirconium, that will be deposited on this filament. So these are the important two processes which comes with respect to the vapor phase refining. But in both the process, the concept is same. First, you are converting your crude metal to that of your volatile compound by utilizing the available reagents. In Mond's process, we have seen those reagents. In Mond's, we have seen that is your your carbonyl, carbon monoxide, and that of your Van Arkel method, it is your iodine. So once you have done the volatile compound, then it is collected in some another chamber where you are going to thermally decompose it at a very high temperature. Of course, we have seen it. Nickel tetracarbonyl, which is subjected to nearly 450 to 470 Kelvin, where we will be obtaining your pure nickel. In the Van Arkel method, your zirconium iodide on a tungsten filament at 1800 Kelvin gets your pure zirconium part. So by this method, so these are the different techniques. Of course, we can't say that each and every technique can be employed for all the metals. Depending upon the properties of your metal and that of your impurities, each technique has its own advantage over a specific metal. And one of the most important thing I just left out when I was dealing with that of your electrolytic refining, which is called as anode mud. I just wanted to just give you the hint of what do you mean by this anode mud. This is mainly a term which is coming with respect to that of your electrolytic refining called as that of your anode mud. So what happens, of course, when you're taking this impure metal rod and you're doing an electrolytic process, so after passing or after certain passage of time, we are seeing that there is a certain heap. A certain heap means like a mountain, small mountain beneath this anode. So this part is called as an anode mud. So what does this anode mud is actually? Basically, they are the impurities which will be present in your impure metal. And what is happening means during this electrolysis, they are getting deposited at the bottom of the anode itself, which may be mainly containing the impurities that can be your antimony, your selenium, your tellurium, silver, gold and platinum. You can ask me, so gold and platinum are also impurities? Of course, because when we are extracting the pure metal of your copper, whatever the other valuable metals it may be, that will be an impurity for us. That is the reason. So here means what is happening, anode mud means they are the impurity heap which is beneath that of your anode containing the impurities like that of your selenium, tellurium, gold, platinum. So that is called as what? Your anode mud. So this completes your topic of your metallurgy.